My name is Tobias Ackels. I'm a postdoc in the neurophysiology of behaviour lab from Andreas Schäfer at the Francis Crick Institute in London. In general, we are trying to investigate how the brain extracts relevant information from the outside world. And our model system to do that is the olfactory system of the mouse, and more specifically the olfactory bulb. So in most cases we use an imaging approach, especially for functional calcium imaging, and to do that we would express a calcium sensor such as GCAMP in, for example, the projection neurons of the olfactory bulb. And we would do that either using virus injections or crossbreeds. So with in vivo imaging, usually the experimenter is limited by light that is being scattered along the way down in the tissue. And when we are trying to image from the projection neurons of the olfactory bulb, even though they are only down to, let's say, 300 microns, there's still a substantial amount of scattering on the way down, especially when it comes to fluorescent dendrites. And in our case, going down to 400 or 500 micrometers to reach the mitral cell layer and do calcium imaging from these cells, three-photon imaging can be very beneficial. What we learned from these three-photon experiments is that less invasive surgeries, such as thinning the cranium or not having to remove the meninges, can still provide you with a very decent fluorescent signal. And this can make your life a lot easier, especially when it comes to chronic imaging experiments. These initial experiments actually make clear that this technique has really high potential. And also when it comes to our experiments, it's easy to imagine further experiments that could benefit from this technique. Of particular interest for us is actually combining the multi-photon functional calcium imaging part with a serial block phase electron microscopy approach. Thus we can correlate the functional properties we get, for example, from a specific subpopulation of neurons in the olfactory bulb with the ultrastructure of this tissue block we get from the EM. It would be really interesting to image from cells that lie deeper in the tissue, like the granule cell population, which is the largest population in the olfactory bulb, or even go down to the ventral part of the olfactory bulb in the in vivo situation and record from these mitral cells on that side. Actually, the customized version of the vivoscope that we have in our lab, you could probably call the first prototype of the hyposcope. And I would say that what has become a lot better in the final version is that you could easily switch between galvo and resonance scanning mode. I had a very good experience with the R&D team from Scientifica, and especially with Christian Wilms. Everybody involved was really motivated and did everything to get this project done